Rahman Rahim. Assalamu alaikum, my students. Now we are entering into the very important phase of the concept of energy. Now, so far we have seen that if there is an object moving in a line on a horizontal line, and you're observing the changes in its velocity, so that means there are going to be the changes in its kinetic energy. And secondly, we have seen that if there is an object which is moving vertically, so its level is changing, its height is changing, so therefore its potential energy will be changing. If it goes higher, its potential energy increases. If it goes downwards, its level decreases, its distance from the ground decreases, so that means its potential energy will be decreasing. Like we have the object, if it's speeding up, the kinetic energy is going up. If it is slowing down, so that would mean the kinetic energy is decreasing. Now, what if we have an object moving on an inclined plane like this? You see that, for example, here it has an initial speed u, and here it has a final speed v. Okay, so here obviously this will have a potential energy which is going to be half mu square, and here it will have the kinetic energy here is half mu square, and here it is going to be half mv square. Okay, now suppose that we have projected this object from here with a speed, let's say 5 meters per second. Okay, and its mass is m right now. Okay, and it just reaches this point B. Now this point B is, suppose this is 20 meters. This distance, this inclined distance is 20 meters. Okay, so if I use this formula right now over here, its kinetic energy is half into m into 25, and here its kinetic energy, since it has gone at rest, it has just reached here. This is the maximum height, the maximum distance it is going to cover, that is 20 meters. So that means v is going to be 0. So at this level, the kinetic energy there is going to be 0, and here the kinetic energy is, let me write it as 12.5 meter joule, and here it is 0 joules. Okay, now if this is the ground level over here, and suppose we have to find that how much is this height over here. Okay, let me see if I can find this without using this this angle. Otherwise I'll just give you what is this angle over here. Okay, now since this is the ground level, so what is the potential energy over here? The potential energy that will be equal to 0. Okay, and it has gained a height h over here, so I can say that the potential energy over here, that is going to be mgh, that is going to be 10 mh. So we have this much potential energy at this level. Okay, now as you have seen that I just told you in the previous video that the change in kinetic energy, that is going to be the net work done by the driving force minus work done by the resisting force. Now imagine that this is a smooth surface, there is no driving force, there is no backward force. We just gave it a push, and we just after giving a push, we just left this particle, and this particle went up to this distance of 20 meters. So that means there is no driving force involved, there is no backward force or the resisting force involved over here. Okay, now I'll be changing this the change in kinetic energy now with the change in energy. Rather than saying change in kinetic energy, I would be saying the change in energy, because two different types of energies are involved over here. One is the kinetic energy, the other is the potential energy. Kinetic energy is involved because the speed is changing, and the potential energy is involved because its distance from the ground, its level is rising, so the potential energy is changing. Okay guys, now please be very clear. Is there any driving force over here? There is no driving force. Okay, is there any resisting force? No, there is no resisting force. Now at this level, some of the students, they do have a right to think that when, for example, if this object reaches here, so there should be a weight over here. Okay, so what about that component of the weight? Obviously, when it is going upward, this is moving in this direction, then this is the component of the weight. For example, this is mg and this angle is given as theta, so this is your mg sine theta. So when this object is moving upwards, then this is obviously stopping this particle to move up the plane. So why are we not saying that this is the resisting force? Now from this video, please be very clear. Whenever you consider this this weight as a part of forces acting on this block over here, then you will never ever talk about the potential energy, because potential energy is basically mgh. Okay, so if in a situation you are considering this weight as a force, it might be a pulling force or a backward force, then you will never ever talk about the potential energy. Okay, one thing. Now the second thing is, if you are talking about the potential energy, then you will not be considering the component of the weight as a pulling or backward force. So please be very clear about it. Okay, so now I'm coming back to my point. So since we are going to talk about the potential energy, so right now we shall talk about two different energies. So I'll be talking about the change in kinetic energy, then the change in potential energy. So that will be the total change in the energies when this particle moves from this point to this point. So this should be equal to the work done by the driving force minus work done by the resisting force. Now this is a formula. If you just remember this one formula, believe me, you can solve all questions on energy, work and energy. I can bet. Okay, so now there is no driving force. Now just focus on this particular situation. There is no driving force, there is no backward force, so that means this is going to be 0 and this is also going to be 0. So I'll be saying that the change in kinetic energy plus the change in potential energy, that is going to be 0 if the surface is smooth and there is no external force involved. This is purely moving under gravity. Okay, so if I take this to the other side, this is going to become the change in kinetic energy, that is going to be minus the change into the potential energy. So we can deal with this minus. This is a very confusing concept, people. You see that now what is going to happen when this particle is, its speed is going to go from 5 to 0. What is happening? The kinetic energy is decreasing. At the same time, its level from 0 is moving up to h. So that means the potential energy is increasing. So if an object is moving purely under gravity, okay, and there is no external force involved, so if it gains the kinetic energy it will definitely lose the potential energy. If it loses the kinetic energy, this is definitely gaining the potential energy. Like you see that when it reaches from this point to this point, it is losing its kinetic energy, but at the same time its potential energy is increasing. Now imagine if the particle was moving downwards from this position to this position. Okay, so what, for example, you just drop it from this level, so this will speed up while going downwards. So what will happen to its kinetic energy? The kinetic energy will increase. And what will happen to its potential energy? The potential energy will decrease. Okay, so we can say that from this that increase in kinetic energy is going to be equal to the decrease in potential energy. You see that this minus sign is justified over here. Okay, now so if you take this to the left hand side, the sum of the kinetic energy and the potential energy, that will always be 0. Okay, so if it is not equal to 0, then it means there is definitely another force involved over here. Okay guys, the video is getting longer, so I'm just going to stop here. You just go through this video again and again, and I'll be coming with another video with the questions, because the formulas that I had to give you, they are over. I'll be giving you a brief recap of the formulas in the next video. Okay, thank you very much.